Okay, now it's a second app. You can also find it in the learning sequence for this lecture after this video. And in this case, it looks very similar to what we have seen before. Okay, so we have proportion for sample, we have sample size, and these two buttons. Okay. However, when we take a sample, so this is my sample, this is the proportion I've got. Now I calculate the confidence interval based on my sample. So I assume that I don't know any parameters for the population. Okay. For example, in my case, I took one sample. The proportion for my sample is 0.7. 95% confidence interval for the population proportion, which I don't know, is between 0.4 and 0.98. Okay, so it means that the true population parameter is somewhere in between, where we don't know. It can be 0.5, 0.6, 0.7. So in reality, we don't know this. But you see, in this case, I was lucky enough to get the true population proportion inside this interval. So this estimate will be correct. Okay. Now I take several samples, like this one, 0.4. In this case, it's smaller than 0.5, but still, you see, the confidence interval tells, okay, population proportion is between 0.10 and 0.7. So, which is correct, because 0.5 is exactly in between. We can't say this more precisely, because in this case, we would take we need a bigger sample size. But for this sample size, it works quite well so far. Okay, so let me take, for example, 10 samples, start with 10. So I took 10 samples, 10 different samples, and in all 10 cases, my confidence intervals has the true proportion inside. For example, in this case, my proportion for my sample is 0.3. Based on that, I can calculate the confidence interval for the population, and it will be between 0.02 and 0.58. And still, this true proportion is inside. Okay, so this is the confidence interval, and this is the true population proportion. You can see that it is inside the confidence interval. Okay, let's take some more. Let's see how often we will have wrong confidence intervals. For example, in theory, it should be 5% of the cases. So far, you can see 3%, 5%. Let me take 100 samples quickly. So 8% so far, 9%. 10%. Okay, I took more than 100 and I got 10%. In theory, it should be no more than 5%. So that's the theoretical probability to get, for example, in this case, it's 95%. It means that in 95% cases, the true population proportion should be inside. Okay, in theory, that works, but you will have to take a lot of samples to make it work correctly. Okay, so that's the idea. So you take a sample. Without any knowledge about population, you use only knowledge about your sample, you can calculate a confidence interval for population parameter. And with a certain confidence, the true population parameter will be inside this interval. So that's the way to make an inference. Now, look, let's change the sample size, for example, to 20 again. Okay. And now you can see that the sample, the confidence interval is smaller. I will reset all statistics and start from the scratch. So let's see how often I will get inside this interval. So again, most of the time, it's quite good, right? So I took 10 samples and yeah, one was outside this interval. And you see the interval gets smaller, it's more narrow. So if you want to have more certainty, if you want to decrease the uncertainty, if you want to make this confidence interval more narrow, just take a bigger sample. So that's the best way to do that. So let me just try to take like 30 or 50 again. And see how many percent will be outside. Okay, so in this case I have 55 and only 4% is outside, which fits the confidence that we use, 95% confidence. So it means 96% out of 55 I've got the estimation of the true population parameter inside this interval. I'll just continue for 100. Let's see if this rule with 5% will work for 100. Again, the bigger sample size, the better these rules work. So in this case, I took one more, and one more. I took 100%, and only in 2% cases, the true population parameter was outside the interval. So in this case, the interval is quite good interval estimate for the population parameter. And then if you take, for example, interval small, let's take like 6, for example. Okay, I need to reset statistics first and then take more. So you can see that it's pretty wide. It's pretty wide, and then quite often the true population parameter will get outside. You will learn later that you have some limitations for how many values you can use for calculation, how big the sample size should be. For example, for proportion, this sample size is too small. Okay, for proportion, you need sample size larger to, for example, for this 0.5, you need sample size at least 10 to calculate this correctly. So in my case, my sample size is too small to use this parametric rule, and therefore I got many values outside this. For every statistic, you will have this requirements for the sample size, and you will see that for most of the cases, sample size 10 is quite good size for making an inference.